Good morning, good morning. So basic mathematics over. I'm audible. Voice and everything clear. Good morning, good morning. Over, sir. Yes, sir. Okay. So now I will start unit and dimension. Okay. So this chapter is important. Every year, unit, dimension, measurement, error, around 3 questions is coming. But this chapter is not only important for this particular 3 questions. That is, it is important for the whole physics because unit is very important. Sometimes we know we are only focusing on the numerical value, and we are not seeing the unit. Due to the unit, we are losing the question. So that's why unit is very important. Everybody has, when you are reading any problem, so everybody has to read the unit very properly. Maybe you are following, they have given some in the MKS, some quantity they have given in the CGS. So we have to follow the one system, and then we have to put in the formula or whatever. Okay. So unit is very important for the whole physics. Okay. So this is the habit everybody has to develop. We have to read the unit also, or any value we are mugging up, then that value we will remember in which unit we have mugged up. Okay. Like simple example, suppose I am saying, good morning, good morning. So like a specific heat of water. If I ask, what is the specific heat of water? What you will say? What is the specific heat of water? What is specific heat of water? 100 C. Oh, 100. In which unit is the 100? You are showing the boiling point of the water. Specific heat, I am asking, answer I am getting the 100 degrees C. Okay. 10 cube or a new answer, 10 cube. Okay, now listen, like we have mugged up the value. Maybe somebody know that it is a 1, somebody is saying the 4,200, but we have never read the unit properly. Maybe somebody has learned that which unit its value is a 1. So its value is a 1 in the calorie per gram degree C. Okay, 540. It is a latent heat of vaporization. Okay, so specific heat of the water we are taking 1 in the unit of the calorie per gram degree C. 4.2 we are taking in the joule per gram degree C. 4200 we are taking in the joule per kg degree C. So according to the problem we are putting the value of the specific heat. So we mugged up that like only 1, but we don't know which unit we have to put it. Okay, so that's why we have to follow the proper unit. So when we are mugging any quantity numerical value, so we have to read the unit also. In the question also we have to read the unit properly. Everybody got or not? Okay. So now I will start with the system of units. So how many system of unit we know? So MKS, CGS, FPS we are using rarely in physics. We will never deal with the data FPS we are using the foreign countries, we are using the FPS more, and in the foreign book you will get FPS data. But here we will deal mainly with the MKS and CGS. So what is the MKS? What is the MKS? MKS is the word M for meter, K for kilogram, and S for second. Meter means length we will put in meter, mass we will put in kilogram, and time we will put in second. Okay. Means when we are following the MKS system, then mass we have to put in kg, then length we will put in meter, and then time we will put in second. So first, like data, any data they have given, maybe combined data they have given. So first we have to, if we are following the MKS system, then mass we have to take in kilogram, length we have to take in the meter, and the time we have to put in second. Okay. Number 2, CGS. Okay. CGS is what? Length we will write in centimeter, mass we will write in gram, and time we will write in second. Third one I'm just writing here. Third one is what? FPS. Okay. FPS is what? Food, pound, and second. Means length we will put in food, mass in pound, and time in second. But only just you have to know we will never use this FPS. Okay. Yeah, online class is coming in app. Now fourth one, these are the 3 systems. In that 2 mainly we will follow. Fourth system is the SI system. What is the SI system? Fourth, somewhere maybe you have seen SI unit is this. What is the SI system? SI system is what? SI unit is what? International System of Units. Okay, don't go sequentially. System of international unit. It is a international system of unit. So what is this SI? Why we have introduced this SI unit when we have the MKS CGS? Okay, so like suppose one example I will ask. Force. What is the formula of the force? Basic formula of the force. Like everybody know F is equal to M into A. This is the basic formula of the force. Everybody know, I think. F is equal to MA. Okay. Where M is the mass, A is the acceleration. Suppose I am saying what is the, if I am following the MKS, I am putting the mass in kg. So this is the kg. Acceleration, what is the unit in MKS? Meter per second square. So acceleration I am writing meter per second square. Okay. So force, MKS unit, what I can say? Kg meter per second square. Kg meter per second square. Everybody getting or not? This is the force unit. Okay. And if I am asking the work or energy, so work or energy unit, what I will get? Energy or work, basic formula is what? If you know or not, doesn't matter. Means I am saying this example why we have introduced the SI system. So force, I can write in the MKS kg meter per second square. Okay. Energy or work are equivalent in the terms of units. So we can say force into displacement. Force is what? Kg meter per second square. Into displacement means meter, then you will get kg meter square per second square. It is the MKS unit of the energy. Okay. Suppose when you are buying the biscuit, and on the biscuit packet or when you are buying the chocolate, it is written somewhere 2 kilocalorie or 5 kilocalorie, something like that they write in the packet. You have seen or not? When we are buying any chocolate or biscuit, in that kilocalorie something has written. But in that place, suppose it is written that 10 kg meter square per second square. In that place, in the place of calorie, suppose they write the 10 kg meter square per second square. So it will be little bit complicated. Normal people, they are saying that easily in the joule or calorie, they know that. But they cannot say kg meter square per second square. So this is a difficult or not? So it will be unnecessarily lengthy also, and it is a difficult. So to represent the unit in the easy way, we have introduced what? SI system. We have introduced the international physics has introduced the SI system. SI system means what they did? Some bigger unit they replaced by on the honor of the scientists. Like force, I will not write kg meter per second square. Force, what I will write? Force, this kg meter per second square we replace by Newton. Okay. So what is the SI unit of the force? Newton. Are everybody getting or not? So this kg meter per second square, in the place of this, suppose I am sending you 10 Newton. So you will get to know or not, I am sending the force data. Suppose I send one data to you, 10 Newton. So by the Newton, you will get to know this is a force. So whole international physics, they are following this SI system. So some unit, what we did, complicated unit or what we are using frequently, we are using on the honor of the scientists, we have given the name. Like force we are giving the Newton, energy, joule, okay, pressure, Pascal, and power, watt, okay. Later you will learn the magnetic field, that is a Tesla, magnetic flux, Weber, okay, electric current, ampere. So many, Coulomb's law, Coulomb charge, we have given the Coulomb. So on the honor of the scientists, we have given the what, some particular name, then it is easy to remember that. Okay, so that's why we have introduced the SI system. Everybody got or not? Understood? So what is the SI system? Everybody got. Second thing, when the SI, they will give the SI system, okay? So suppose they have given the force data in the Newton, okay? And which unit we have to follow? Like they have given the force, but I have to use the length, I have to use the mass. So when we are following the SI, most of the SI unit and the MKS unit, in our syllabus what is there? Most of the SI unit and MKS are same. Most of the SI unit and MKS are same. Like if I am saying the 1 Newton force, I am saying 1 Newton force, so that I can write as a 1 kg meter per second square also. 1 Newton force, I can write 1 kg meter per second square also. Like 1 joule I can write 1 kg meter square per second square. Everybody getting or not? So most in our syllabus, whatever the quantity we will use mostly, MKS value, suppose they have given the SI unit. So that SI unit means we have to follow the MKS unit for the other quantities. Means if I want to put the mass in that, so I will put the mass in kg. If I want to put the length in that, so I will put the length in meter. Everybody got or not? So when they given the SI unit, of any quantity, so rest quantity we have to follow what? MKS. Everybody got or not? Up to this okay? Means suppose I am saying the energy joule, then mass I will put in kg. If I required mass, then I will put the mass in kg and I will put the length in meter. Okay. One example is there. It is a CGS, but that is a SI unit. It is a CGS, but it is a SI unit. That is a poise. Poise later you will learn, but always we will think that except the poise, always means when we have the SI unit, then other unit we will put in the MKS. Okay, poise is the CGS unit, but that is a SI unit. Poise, on the honor of the Poiseuille, it has given. Later you will learn in the coefficient of viscosity. Okay, otherwise here what we will do, SI unit means SI unit if they have given, then directly we can say SI unit means other values we will put, other variable we will put in MKS. Okay, so here international system example, what we can say, like Newton, Joule, Pascal, etc. Okay, so these are the system of units. Now next is the fundamental or base quantity. Fundamental or base quantity. So I think everybody know what is a fundamental. What is a fundamental quantity? What is a fundamental quantity? Like we will learn. We know the large number of physical quantity. Okay, and maybe some quantities we don't know. It is not in our syllabus also. So if we are giving the particular name to all quantities, so it is very difficult to remember all quantities. Okay, so what we did, what international physics has done, they have made the 7 quantity as a fundamental. They made the 7 quantity as a fundamental. Then what will happen? Other rest of the quantity, whatever the quantity is there, rest of the quantity we can represent in the terms of these 7 fundamental. Okay, so 7 quantities we have taken fundamental. So rest of the physical quantity we can represent in the terms of these 7 fundamental. Okay, so what is which quantity we have put in the fundamental? Means what is the definition of the fundamental? The quantity that does not depends on each other, I can say, or the quantity, one quantity cannot express in the terms of other. One quantity cannot express in the terms of other, that we put in the category of fundamental. So if definition is required, then we can say the quantities are independent of each other, or we cannot express one fundamental quantity into the other. So those quantity we put in the category of fundamental. Everybody got or not? And rest of the quantity that we can write in the terms of fundamental, they call derived quantity. They call derived quantity. So what is a fundamental quantity? The quantity that is independent of other, independent of each other, or we cannot express those quantity in the terms of other. Okay, that we put in the category of fundamental. There are 7 fundamental quantities. Rest quantity we can represent in the terms of 7 fundamental. That quantities are called derived quantity. Everybody got or not? Okay, so there are 7 okay, so means for the fundamental we have to check we cannot express one quantity in the terms of other quantity, other fundamental quantity. Okay, so 7 fundamentals are what? Number 1, mass. Mass in the dimension we will use the symbol m. Length, it is what? L. Number 3, time, that is T. Number 4, electric current, it is A. Number 5, temperature, that we are writing symbol K. Number 6, amount of substance, that is mole. Number 7, luminous intensity, that is called, its unit is the candela, so that symbol we have given CD. Okay, so these are the 7 fundamental quantity, okay, that you have to know. But in the physics mainly we will deal with the top 5, like first 5 fundamental quantity. Luminous intensity, earlier one chapter was there in the physics, there we were learning the luminous intensity, but now it is not there. So luminous intensity we will never talk about that. Amount of substance, mole, we are using in the chemistry mainly. So here in the dimension mainly we will deal with the first 5 units. Okay, everybody got or not? And other quantity we can express in the terms of these 7 fundamentals, so they called derived quantity. Like suppose I am asking force. Force is the fundamental or derived? So force is the derived quantity, because force I can express in the terms of ml and t also. Everybody getting or not? So except these 7 fundamental, the rest quantities will be derived. Okay, like suppose I am now mass and length. What is it from the definition of the fundamental? Suppose I am saying what is the unit value of the length in the mass? Can I write the mass in the terms of length? No. Can I write the length in the terms of mass? No. Can I write the time in the terms of mass and length? No. Means these are the independent quantities. That's why these quantities we have put in the category of fundamental. Okay. Completed. So other quantity is called can be expressed in terms of fundamental or base quantity. Those are called Those quantities are derived quantity. Okay. So if you understand the definition of the fundamental, then one question I'm asking, okay, suppose I'm saying length, velocity, time. Suppose these 3 unit I gave, and I'm asking, can I take these 3 quantity as a fundamental? Can I take these 3 quantity as a fundamental? Suppose I don't know the fundamental system, the 7 fundamental I don't know. So I'm asking that can I take these 7 as a these 3 quantity as a fundamental? No. Why? We don't know about the 7 fundamental quantities. Okay, we know only the definition of the fundamental quantity. Okay, so can I take these 3 as a fundamental? No. Somebody saying velocity is derived. Okay, because I'm saying that forget about the 7. You don't know 7 fundamental. Then can I take these 3 as a fundamental? Okay, velocity will be derived. We cannot take. Okay, another example I will say. Can I take these as a fundamental? Can I take mass, velocity and time as fundamental? No. Can I take mass, velocity and time fundamental? No. 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 Means most of you have giving the answer no, because you mucked up 7 fundamentals, so that's why you are taking the velocity is the derived. Now what I said, if this type of question they are asking, so forget about that we have mucked up the 7 fundamental quantity, because they are asking that we take as a fundamental. Suppose we are changing our fundamental system, suppose this 7 fundamental we are not taking, we are changing the fundamental system, can we take these 3 as a fundamental? Don't think like that I know the 7 fundamental, that's why their velocity is not there, so this I cannot take. I am saying can be taken. I'm not asking mass, velocity, time is fundamental or not. I'm asking, can I take the mass, velocity, time as fundamental? Can I take the length, velocity and time? Suppose I'm making the new fundamental system, can I take these as a fundamental? Question everybody got or not? I'm not saying length, velocity and time are fundamental or not. Everybody know velocity is the derived, okay, because 7 fundamental we mucked up. But here I'm saying, can I take these 3 as a fundamental? So listen, first one suppose length, velocity and time according to the definition of fundamental. If I am taking the length and time fundamental, if I am taking length and time as a fundamental, then velocity I can write as what? V is equal to distance upon time, then or displacement upon time, that is a L by T. So if I am taking the length and time fundamental, then velocity I can write in the terms of L and T. So velocity will be derived. Velocity will be derived. Okay. If I am taking the velocity and time fundamental, suppose first question first I am discussing. If velocity and time I am taking fundamental, then length what I can write? L is equal to V into T. It means if I am taking V and T as fundamental, the length will be derived. Okay. If I am taking the velocity and length as a fundamental, if I am taking velocity and length as fundamental, then time I can say what? L by V. Then time will be derived. Everybody getting or not? It means any 2 I can take as fundamental, then third one will be the derived. Not necessarily only velocity. Don't think like we have mucked up the 7 fundamental. I'm not asking which is a fundamental, which is not the fundamental. Okay, can I take? So in the first answer, what we will give? Any 2 can be fundamental, but third one will be derived. Okay, not only velocity. I can take the velocity time fundamental, then length will be derived. Are everybody got or not? Now come to the second example, mass, velocity and time. Okay. Now you will give the answer. If you understood the first one, you will give the answer. Can I take the mass, velocity and time as fundamental? Can I take the mass, velocity and time as fundamental? Can I take mass, velocity and time as fundamental? Very good. Means everybody understood? Means yes, yes, we can take. Yeah, why? Because mass is independent of velocity. Mass is independent of velocity. I cannot express the mass in the terms of velocity and time. I cannot express the velocity in the terms of mass and time, and I cannot express the time in the terms of mass and velocity. That's why second example, second one I can take. I'm not asking that they are. I can take as a fundamental. First one cannot be taken as fundamental. Everybody understood or not? So first cannot be taken as and second can be taken as okay. Completed. So this fundamental and derived clear to everyone. Definition of the fundamental, everything. Okay. Now listen. Except these 7 fundamental, there is a 2 supplementary quantities unit. That is neither we have put in the category of the fundamental, not in the derived. Those are the what? Angle, plane angle and the solid angle, plane angle and the solid angle. So there are the 2 supplementary unit that is not in the category of the belongs to the category of the fundamental and nor in the derived also, we can say. Okay, so they are the 2 supplementary unit. First one is what? Plane angle. Suppose I am representing theta. Second, I can say what? Solid angle I am representing by. Okay. So there are the 2 supplementary unit. It does not belong to the fundamental and does not derived. So that is a what? Plane angle and the solid angle. What is the unit of the plane angle? Everything about the plane angle we have learned in the basic mathematics. Plane angle we can say what? Arc by radius. Arc by radius. And unit what we have learned? Radian. And this I can say what? Solid angle I can say what? Area by r square, radius square, and its unit is what? It's a radian. Okay. Now, what is the meaning of the plane angle and what is the meaning of the solid angle? In the short, I will say plane angle means, suppose I am asking, I have given the one arc, and I am asking, joining the arc at the center or somewhere, and I am asking what is the angle it is subtending. So that angle is the plane angle. So when we are asking the angle due to the arc, then we will measure what? Plane angle. Okay, everybody getting or not? So due to the arc, when we are finding the angle, then that is a plane angle. Means you can see that will lie in the plane. Okay. If due to the any area, suppose just think about the suppose you have the one watermelon. Okay, watermelon you are cutting several pieces. In the summer you are eating the watermelon. Think about the piece of the watermelon. That is a green area, and that red is a pointed like this. Okay, when you are cutting. So red is a pointed like this. Or birthday cake when you are cutting, so the shape of the birthday cake is like this. What is a piece of the birthday cake you are getting? It is a like this. Yes or no? Here it is a area and here it is a pointed like this. All are joined. Okay. So in that first one I said arc. Here if it is a plane, it is a arc. So this angle I will say it is a plane angle. Okay. But if it is a area, and I am joining all the points, then that will be what? Solid angle. So area angle subtended by the area at the point, that we can say what? It is a solid angle in the simple way. And area subtended by the arc, we can say it is a plane angle. Everybody got or not? Like in a cone, then we measure the solid angle. Completed? Okay. So So next is the unit of length, because that has given in the unit, everybody know the meter centimeter relation, millimeter relation, that everybody has to know. I will write here also. There are the three particular unit also they have given the length unit, okay, that you have to remember, because in the JEE it is given in the NCERT, and the 2 year back they asked in the JEE main also, among the given option which is not the unit of the length, okay. So meter, centimeter, millimeter, everybody know, okay. Like what is the relation? 1 meter is equal to 100 centimeter, and 1 centimeter we can say what? 1 centimeter is equal to 10 millimeter. Normal scale we get this, because two bigger division, in between the two bigger division 10 small division are there, the scale what we are using. So it means bigger division consecutive is what? 1 centimeter, and 1 centimeter in between divided into the 10 part, and that each part is the 1 millimeter. So this relation we can say 1 centimeter is equal to 10 millimeter, okay. Next, 3 unit, that is a unit of the length. Now listen, that is a one is the light year. Light year, maybe somebody think that it is a year, so it is a unit of time. So light year is the unit of the distance. Light year is the unit of the distance. It is the distance traveled by the light in 1 year. Light year is the unit of the distance traveled by the light in 1 year. Similarly, astronomical unit. Astronomical unit, it is the average distance between the earth and sun, okay. And third one is the parsecond. Parsecond is also the unit of the distance. It is the distance of the earth orbit at which earth is subtending an angle of 1 arc second, okay. So these three, again I am repeating, light year, astronomical unit, and parsecond. It is also the unit of the length. Maybe if they will give this option, we have never used it, so you will think that what is astronomical unit, what is this unit, okay. So in the JEE main 2 year back they asked this question, which is not the unit of length. So light year is the unit of length, astronomical unit is the unit of length, and the parsecond is also the unit of length. Everybody got or not? So that larger unit I am saying. Light year, astronomical unit, and okay. Completed. Now next is the parallax method. So what is the parallax method? So parallax method basically, like suppose I want to find the distance of the moon from the earth, or distance of the sun from the earth. So we cannot measure by the scale, we are taking the scale and we are measuring, okay. So to find the larger distance we are using the parallax method, okay. The concept, similar concept I have discussed in the basic mathematics, okay. So parallax method is what? It is used to find the largest distance. Okay, so what we have learned in the basic mathematics, suppose I am standing on the moon, and I am observing the earth, okay. I want to find the distance of the earth from the moon, okay. So this is the suppose earth. This I am taking the diameter. I am taking capital D, okay. And suppose this is a moon. Here I am standing. This diameter I am taking A, B. Suppose from the moon we are observing. I am observing the earth, okay. And I am observing the end of the diameter. So this is the one end of the diameter. This is the one end of the diameter. So if I am joining this point from here and this point from here. Okay, So that line of sight I know. Accordingly, I can find this angle. Means suppose the diameter of the earth making an angle theta at the moon. Diameter of the earth making an angle theta at the moon. Okay. Everybody getting or not? I want to find the distance between the moon and earth. Okay. And this distance is large. So that I'm using the parallax method. So parallax method basically we use to find the large distances. Okay. How we can find? Suppose we are standing on the moon and I am observing the earth diameter, end of the diameter. So I join the diameter, so means I know that how much angle it is making. I can measure that angle, how much angle it is making at the moon. Okay. Now suppose the distance between the earth and moon is the x. I'm taking the distance between the earth and moon is the x. Now what I said, everybody know that they are very far. Like suppose I'm observing the sun is very far from the earth, moon is very far from the earth. So this, they are very far, means distance is large, so angle will be very small. Angle they will subtend the small angle at the eye. Angle is small, okay, angle is small. Then if you remember in basic mathematics I said arc and straight length will be equal. If the angle is small, then we can say the arc length and straight length are equal. So this diameter is making the small angle at the moon. Okay, diameter is making a small angle at the moon. So this diameter I can take like a arc also, because arc and the straight length will be same. This everybody remember or forget? Basic mathematics I said when for the small angle, like suppose this is the circle, I am taking the small angle, so small angle means this arc length and this straight length will be equal. We can take it is a nearly equal. So same way here I can say this arc length and straight length will be same. Okay, when the angle is small. So here theta is small. Then now I can say what? Angle is equal to arc. What is the arc? Arc I can take as a AB upon radius. Radius what I can take? Distance between them, that is a x. From that I can get the value of x. Everybody got or not? Okay. But I said for this formula, one thing we have to remember. When we are applying this formula, angle unit, which unit we will put here? Angle unit we will put in radian. So theta must be in so okay. So means if they have given the in the degree, then first we have to convert into the radian, then we can put in this formula. Everybody got or not? Okay. Completed? Okay then. Now one small question, that is the NCERT solved example. Earth diameter makes an angle (1°54' at moon, then find distance between them if diameter of earth 1.28 into 10 to the power 7 meter. If theta is large, then distance will not be large, na? Then theta is large, then we simple way by the using if theta is large, if you are saying so theta is large, then distance will be not large. Then we can use the triangle property. By the triangle property, we can get the answer. Okay, if theta is not large, if theta is very large. So like it will be simple triangle, it will be simple triangle, so we can find the distance. Okay, so jata. Now we have to find here distance between the earth and moon. Okay, so here diameter I gave and angle I gave. If you remember in basic mathematics I said if they have given that radian, degree they given, minute they given, second they given, so first we have to convert the whole angle into the degree and then degree that we will convert into the radian. Okay, so they gave the 1 degree 54 minute, 1 degree 54 minute. So then theta, what I can say, theta is equal to 1 degree 54 minute. 54 minute I can say 54 by 60. Then you will get in degree. 1 minute is equal to 60 second, 60 minute. 1 hour is equal to 60. 1 hour is equal to 60 minute. And hour we are taking as a degree. Everybody getting or not? So here 54 minute they given. So 54 minute, what I can say, 54 by 60 degree. Now 9 6 are 9 10s are. Then what I got? 9 by 10 is the 0.9. So this we got what? 1.9 degree. I got in the degree, but I have to put in the radian. So how we can put in the radian? 1.9 into pi by 180. Then that you will get in radian. Now angle I got in the radian. Okay. Then what we will do? We will use the formula angle is equal to arc. What I will take? Diameter upon radius. What I will take? Distance between them. Okay. Now put the values. So what is the theta? Theta is the 1.9 into 1.9 into pi by 180. That is equal to what? Diameter I gave 1.28 into 10 to the power 7, and distance suppose I am taking x. Okay. So what is the x value? X value what I got? 180 into 1.28 into 10 to the power 7 upon 1.9 into pi. And that you will get in meter. Sir, are you in Penamolo? Yes, I am in studio. Online class we take from the studio. Okay. This everybody got. And if you want to if suppose this type of question they are saying, and we have to solve what? Approximate value. So pi you can take. For the closer option, you can check. If the options are not very close, then we can go from the approximate calculation. Pi I can take 3, then 3 and this 80, 180, it will get 60. Okay. 1.28 you can take 1.3, 1.3 and 1.9. Easily you can solve. Okay. And check the which is the closer answer. Are everybody getting or not? You will solve. Completed. When the class is going on, so many queries are there. Sir, third track there or not? Yes, it is there. Okay. Okay then. So this is the parallax method. Now we will talk about the dimension. Okay. Sir, what happened? .46. Very good. You have the calculator. That's why you have calculated up to the decimal 3 places. Okay. Up to this, anybody has doubt? Up to this, everybody got or not? Okay. So first, if any dimension you, suppose I am saying any dimension you remember, then you can say the dimension of any quantity, suppose you marked up. Dimension of any quantity you marked up last year in the class 12th, any dimension you marked up, who will say? Any quantity dimension, just write any quantity dimension, who marked up? Nobody is replying. Okay. So, okay, I will say. So, suppose maybe somebody marked up the E, okay, just now E ml2 t minus 2. Okay, very good. So, dimension, somebody is saying that dimension, velocity dimension LT minus 1, not the MT minus 1, LT minus 1. and somebody mugged up the dimension of energy ml2 t minus 2. Okay, now listen, later we will say all the dimension, but first one thing, what maybe suppose sometime they will ask a question that is based on the definition of the dimension. So first thing, we have to know that what is the meaning of the dimension. In the normal way, like suppose I am also talking, so I will say, what is the dimension of the force? You will say mlt minus 2. What is the dimension of this quantity? This, okay? But what is the actually meaning of the dimension? Dimension is what? Now listen first. What we mugged up, like suppose area dimension or volume dimension, whatever you mugged up, or velocity, suppose I am taking. Velocity LT minus 1. Velocity we are writing as a meter per second, so that is LT minus 1. So LT minus 1 is the dimensional formula of velocity. LT minus 1, in normal talk we are talking about the dimension only. But basically it is what? LT minus 1 is the dimensional formula of the velocity. Dimensional formula of the velocity. What is the meaning of dimension? Dimension is the power of fundamental quantity in the dimensional formula. I repeat again. What is the meaning of dimension? Dimension is the power of fundamental quantity, power of fundamental quantity in the dimensional formula, in the dimensional formula. Like I am writing the LT minus 1. LT minus 1 is the dimensional formula of velocity. It is the dimensional formula of velocity. Now if I will ask, what is the dimension of the L in velocity? What is the dimension of L in velocity? 1. What is the dimension of time in the velocity? Minus 1. What is the dimension of mass in the velocity? 0. Everybody got that meaning of the dimension or not? So you have to know, normal talk we will talk, what is the dimension of the force, what is the dimension. But we have to know what is the meaning of dimension and what is the meaning of the dimensional formula. Clear to everyone? Like energy or force, I am writing mlt minus 2. mlt minus 2. So dimension of the mass in the force is, dimension of the mass in the force is what? 1. Dimension of the L in the force is what? 1. Dimension of the time in the force is what? Minus 2. Okay. Okay. So common sense question and basic definition based question. What is the dimension of the mass in the length? What is the dimension of mass in the length? Tell fast. What is the dimension of mass in the length? 0. Very good. Means that is the meaning of what? Fundamental quantity. Means the quantity does, one fundamental does not depends upon the other. Means the dimension of the mass in the length 0. Dimension of the length in the time 0. Dimension of time in the mass and length 0. Everybody getting or not? That is the meaning of the fundamental. Means in a one fundamental, dimension of the other fundamental quantity will be 0. We cannot express one fundamental in the terms of other. Everybody got? Okay. Now I will write some dimensional formula. Now first listen. There are so many physical, like 50, 60 physical quantities, 70 physical quantities you will learn in the whole physics. Okay, and all dimension we cannot mug up. Okay, and right now I cannot say all the dimension because so many quantities you don't know, because I'm taking like you are the beginner, means you don't know the quantities. Okay, so few quantities here I will say. And it is your responsibility as you are learning the chapter, okay, and you are learning the new quantity, any new quantity. It is your responsibility. You have to find its dimension. So first you will remember, later like different chapter, you will learn the different formula. Okay, for the quantity you will learn some formula. Any new quantity you learn, like electric field you learn. So electric field, for the electric field, basic formula you will learn force by charge. Okay, that is the best formula for the electric field. Okay, now E is equal to F by Q. Then you will find the dimension of the electric field by using that formula. It is your responsibility. Teacher is saying or not, because that time they will directly leave the dimension, because they will expect that you can find the dimension by own. So here I will say how to find the dimension by using the formula. Which dimension you have to remember to solve the problem first. Okay, but I will not discuss about the whole dimension. You will learn, you will get to know the new quantities in the revision. Then you will be more comfortable. That time you will complete the whole physics. Then we can discuss the different problems of the dimension. Okay. Which quantity I am putting the star mark, that you have to remember the dimension of that. Okay. So first simplest dimension, like suppose I am saying distance or so listen, whether I am saying distance, definition, they are different. Okay. Distance, displacement, okay, radius, diameter, perimeter, okay, arc, means they are the different quantities. Radius, diameter, arc, everybody know or not? Radius, perimeter, arc, distance, displacement, all are the different, but all are the basically representing the length only. Okay, all are representing the length. That's why their dimension is what? L. Their dimension is what? L. So distance, displacement, radius, arc, diameter, perimeter, all we can take, all we can represent by L. So its dimension will be what? L. Okay. Number 2, velocity or speed. So velocity or speed, what is the basic formula? So basic formula is what? Speed is the distance upon time, velocity is the displacement upon time. So displacement is L, time is T. Then what is the dimension I got? LT minus 1. Suppose I am saying in the terms of unit meter minus meter, what you will get? Meter minus meter, what you will get? So velocity dimension is what? LT minus 1. These all you have to remember. If I am saying meter minus meter, what I will get? 0. Okay. So I have not given the magnitude, means what will be the answer? Meter minus meter means I am subtracting the two lengths. Suppose I am saying 10 meter minus 5 meter. Ashwin, 10 meter minus 5 meter. Ultimately, you will say the meter. The difference will come meter. Suppose 10 kg minus 4 kg. 10 kg minus 4 kg, what I will get? 6 kg. So ultimately, I will get the mass. Mass minus mass, I will get the mass. Length minus length, I will get the length. Means I can say one thing. Means any quantity and the change in the quantity. Any quantity, suppose I am saying, or change in the quantity, they will have the same dimension. Whether I am saying the length or I am saying the change in length, both will have the same dimension. Everybody getting or not? So any quantity and change in the quantity will have same dimension as of quantity. Okay, that I am writing here. Okay. So here, third I am asking, what is the dimension of acceleration? So acceleration, basic definition is what? Change in velocity per unit time. So we can say what? Delta V by T. Now delta V is what? Change in velocity. Change in velocity will have the same dimension as of velocity. Then LT minus 1 upon T. Then what we got? LT minus 2. Okay. Number 4. Force. Force, simple formula we know what? F is equal to ma. F is equal to ma. Then now we can say what? M is the M. Acceleration dimension, what we got? LT minus 2. What dimension I am writing on the board? This dimension, everybody has to remember it to solve the problem fast. Okay. What is the dimension of the force? MLT minus 2. Work or energy. Work or energy, in the terms of dimension, they are similar, work or energy. So work or energy, if you require, you can go through the any energy or work formula. Work basic formula, we know force into displacement. Energy, suppose you are using kinetic energy, half mv square. Potential energy, you are using mgh. So easy way is what? Force into displacement. Because we can get the work dimension easily by using force into displacement. Force dimension already we know, so that we can say force into displacement. Force dimension I got MLT minus 2. Displacement is what? L. Then what is the dimension? ML2 T minus 2. Okay. Suppose I am asking density. So density, what is the formula we have? Density is the mass by volume. Mass by volume. Mass is what? M. Volume, I said in the basic mathematics, volume is any volume, always 3 dimension will get multiplied. Length into breadth into height, R cube, side cube. Means volume unit is what? The side cube. So then what is the dimension of the volume you will get? L cube. Then what we got? ML minus 3. Area, 2 dimension will get multiplied. Volume, 3 dimension will get multiplied. Electric charge Q. So Q and current relation we know, I is equal to Q by T. Rate of flow of charge is called the current. So current, electric current is the fundamental quantity. So Q, what I can say? I into T. I, what we are writing? A, and time is the T. So dimension of the charge, what we can say? A into T. Linear momentum. Its dimension, no need to mug up. Only the basic formula I think everybody know. Okay. Linear momentum P, that is equal to what? Mass into velocity. Then mass dimension is M, velocity dimension is LT minus 1. Okay. Number 9, pressure dimension. Pressure or stress, that will have the same. So this also you have to remember. Pressure is what? Force per normal force per unit area. So that is a F by A. Basic formula we can say. Force ML T minus 2 and area is what? L square. Then what we got? ML minus 1 T minus 2. That is the dimension of the pressure. Completed. So for the dimension, we will always use the simplest formula. For the dimension, we will always simplest formula. Means suppose you are thinking the formula in which another unknown quantity is coming. So then what will happen? First you have to find those unknown quantity dimension. Then you can find the given quantity dimension. So always think the basic formula or the simplest formula of the quantity so that easily you can find the dimension. Okay. Next important dimension is gravitational constant. Okay, gravitation constant capital G. So any formula we know in that for terms of capital G, Newton's laws of gravitation, gravitation force, F is equal to what? G m1 m2 by r square. Okay, then to get the dimension of G, what I can write, capital G is equal to f r square by m1 m2. I know the dimension directly, and I expect that everybody has to remember the dimension of capital G, because so many times we are directly using capital G dimension. Okay, so now dimension of G, I can say what? I will put the f dimension mlt minus 2. R means distance, distance square means L square, upon mass into mass, I will get what? M square. Now what is the dimension of G I got? Dimension of G is m minus 1 L3 t minus 2. One here directly asks what is the dimension of the capital G. M minus 1 L3 t minus 2, that is the dimension of capital G, and try to remember it. Slowly practicing more, then you will remember. M minus 1 L3 t minus 2. Okay. Completed. Suppose I am asking the gravitation potential dimension. Okay, so later in the gravitation chapter we will discuss what is the gravitation potential formula. You will maybe you learn also minus gm by r. It is a gravitation potential due to point charge. Okay, but what I said, we have to think the basic formula or simplest formula to get the dimension. This question asked in the 2022, what is the dimension of the gravitation potential? Matrix match they given. So gravitation potential simplest like definition is what? Work done per unit mass, work done in bringing a unit mass from this point to this point. Okay, so work done per unit mass, that is a basic formula, basic definition we can use to get the dimension of V. If I'm using the minus gm by r, I have to put the first G dimension, must be you remember, then it is okay. If you forget, then first you will find the G dimension, so it will be unnecessarily lengthy. So basic is what? Work gravitation potential, we can say V is equal to what? W by m. V is equal to W by m. That is the simplest formula to get the dimension of the gravitation potential. Okay, so now what is the dimension I can write? So dimension of V, work dimension we know m L2 t minus 2 upon m cancel out, what I got? L2 t minus 2. Everybody got? So by using your common sense, suppose I am asking what is the electric potential. Suppose you want to find the dimension of electric potential. Then what will be the basic formula I can use? Electric potential, what is the basic formula I can use? Gravitation, we are dealing with mass. Electric potential, electrostatic, we are dealing with the charge. So what is the basic formula of the electric potential? V is equal to W by, no, both are not the same. Gravitation, we are dealing with the mass, and electric potential, we are dealing with the charge. So that's why same definition, but work done per unit charge. Numerator will be same, but denominator will be work done per unit charge. Now work done dimension is what? Work done is mL2 t minus 2, and charge just now I got 80. Q is equal to IT. Okay. Now from this, what is the dimension I will get? Dimension of V is equal to m L2 t minus 3 a minus 1. That is the dimension of the electric potential. Everybody got? So these are the simplest formula, like you will learn so many formula, but it is the simplest formula to get the dimension of these quantity. Okay. Completed. Number 13, Planck. Planck constant. So in the basic chemistry, maybe they said this formula also for the photoelectric effect they discussed. Planck constant, any formula, like simplest formula is what? E is equal to h into nu. E is equal to h into nu. Nu is what here? Nu is the frequency. Nu is frequency. Later all formula, maybe you know that it is okay. If you don't know this formula, so in different chapter, all these formula you will remember. Okay, you will get. So here nu is the frequency. So frequency is what? 1 upon time. So nu dimension, I can say what? Dimension of nu. That is equal to what? 1 by t. Okay. Now here I can say what is the dimension of h? So E dimension I will get ml2 t minus 2 is equal to what? Dimension of h into 1 by t. Now cross multiply, what is the dimension of h I got? Dimension of h is equal to ml2 t minus 1. Everybody got? So now 2-3 more dimension. Now I will say the formula, you will write the dimension. Okay, if you learn then how to get the dimension. Up to this, okay? Completed. Now suppose I am asking, what is the dimension of the constant? Suppose somewhere any relation, in the physics we got some relation, and in that relation they have given this quantity C is the constant, this quantity K is the constant. Okay, so what is the dimension of the constant? Suppose I am writing the relation, velocity is equal to C into T square, where C is the constant. What is the dimension of C? Suppose this type of relation I am writing, velocity is the ct square. What is the and where c is the constant? So what is the dimension of c? 1. 1 is the dimension. 1. There is a meaning of 1 in the dimension. 0. Next option. M0, L0, T0. Okay, very good. 0. Dimensionless. Okay, dimensionless. 0. Now listen. There are the two types of constant. Okay, like constant when we are saying, so one is the numeric constant. Numeric constant means number. Like suppose I am saying what is the dimension of 5? So you will say that 0. What is the dimension of pi? Pi is the number 3.14 or 22 by 7 we can say. So pi, what is the dimension of pi? 0. But what is the dimension of gravitational constant? Just now we have find the dimension. So gravitational constant is a physical constant. It is a physical constant. Number is there, numeric constant, then we can say it is a dimensionless. Okay, but when any physical constant is coming, then it will have dimension. Gravitational constant, permittivity, Planck constant, permeability, all are the like constant for the given medium, but they have the dimension. So numeric constant, number will not have dimension, but the physical constant will have the dimension. So when somewhere they are saying this quantity is constant, don't become more intelligent, it is a constant. So that's why it is a dimensionless. Because here it represents the what? Number. If they have written like I am saying that y v is equal to 2t square, so 2 is the number. Okay, it is a dimensionless. But here I write v is equal to ct square, so here it is representing the physical constant. So here it will have the dimension according to the given equation. Everybody got or not? So we will not say that constant will have the dimension 0. Physical constant will have the dimension, number or the numeric constant will be dimensionless. Everybody got or not? So in any problem they are saying this quantity is constant, don't say that it is a constant, so that's why it will be dimensionless. Understood? This is the mistake students are doing. They are saying this quantity is constant, so they are saying it is a constant, so that's why it is a dimensionless. Okay? Clear? Okay, so suppose I am saying the permittivity that we are representing by epsilon. If you remember the symbol or formula, that is okay. Otherwise, just I am writing the formula. You have to find by using the formula. You have to find the dimension. Okay. So permittivity we are using in the Coulomb's law. Force between the two charges we are writing as 1 by 4 pi epsilon into Q1 Q2 by R square. Okay, that is a force Coulomb's law, force between the two charges. It is the simplest formula to get the dimension of the epsilon. Okay, now here epsilon, what I can write, epsilon is equal to 1 by 4 pi f into Q1 Q2 by R square. Okay, from this I can get the dimension of epsilon. Now 4 pi is the number, 4 pi is the number, 4 pi does not have dimension, but force dimension is what, m l t minus 2. Okay, q1 q2 charge is what, 80, so a square t square, and r is the distance, distance square means what, l square. Now you will say what is the dimension, m minus 1, L, L2, L3, L minus 3, T minus 2 will go up, T to the power 4, A square. That is the dimension of the permittivity. Okay, no need to mug up this, only the basic formula you have to remember. Okay, and by this way easily we can find the dimension. Completed? So coefficient of viscosity, coefficient of thermal conductivity. Okay, these are the important dimension. But these dimension we will learn when we will learn those chapters. Okay. Magnetic induction, electric field, all dimension we will learn when we will learn the chapter. Okay. And in the weekend also, if we are giving the question, then we will give the formula, or simple formula that we can expect that you should know. That only we will give. Okay. Last one is what? Suppose I am saying dimension of pressure gradient and velocity gradient. Okay. So pressure gradient means what? We have learned in the basic mathematics, gradient is the slope. Slope is what? Tan theta. Tan theta is what? dy by dx. Tan theta is what? dy by dx. Gradient means, again I am repeating, gradient means slope. Slope is tan theta. Tan theta is what? dy by dx. Okay. Suppose in the place of y, I am taking the pressure. So I will get dp by dx. dp by dx is what? Pressure gradient. Suppose I am saying dv by dx, then it will be velocity gradient. Okay. So means gradient means we have to take the d by dx. So I am asking the pressure gradient dp by dx. So dp, d represent the small change, delta large change we can write, d we can write small change. So dp is basically change in pressure. Okay. So dimension of dp by dx, what I will get? dp I can say change in pressure is the pressure, m L minus 1 T minus 2. That is the dimension of the dp. Pressure dimension you have written also. Dx is what? L I will take. So what is the dimension I got? M L minus 2 T minus 2. Everybody got the pressure gradient. Gradient means that quantity by dx. Okay. Dx is what? Change in x, change in distance. So that is what? L. Okay. Number 2, dimension of velocity gradient. Velocity gradient, what I will write? dv by dx. Now dv dimension is what? V dimension. That is what? lt minus 1 upon L. L cancel out, what I got? T minus 1. So dimension of the velocity gradient. Okay. Completed. So these are the basic dimension I said. Next class I will discuss the different problem. Today at 7:30 evening, you will get the message also. I'll ask to send the messages. Today 7:30 evening, I will take the class around 1 hour 15 minutes. Okay, because first 2-3 days they have not allotted the classes because the more batches was there. Okay, so 7:30, and you will get the message final time and everything. Okay, 7:30 will be the time. Everybody got? Okay then, bye bye. I said what I put is the star mark, that only you have to remember, okay?